Yes, so this one says Shana selected one fruit at random from a box containing 40 mangoes and 25 apples. She ate it, then random select another. Can anyone please share with us how did you do part A? How did you begin? It says without replacement, selection without replacement. What did you do? Right, so first start, she says she first started by constructing a tree diagram. Okay, now we are in Word and we have a template already ready-made. That selection without replacement. So let's check it out. The tree diagram explain. Let's look for one, or we can use the same one, and just modify. It doesn't really matter. Okay, it does not really matter, but we can use this one there, selection without replacement. So let's just check it out. Just highlight this there. Press shift. Right. Okay, and then we can just copy this. Yeah, it is all grouped up. Copy it. Control C. And bring it to our. Let's put this a little small to see what we're doing. All right, so it's going to come right here. Let's see if it can fit. Control V. Centralize it a little bit. Come on, stop being stubborn. Okay. There's a lot of little figures, so right. So here we have a template of the selection without replacement. Okay, it's a lot of figures, so it's okay. So here we have a template of the tree. As she said, she began by drawing a tree. Okay, and we can just modify this tree to suit the information that is in the question. Is 30 mangoes and 25 apples. She ate it, then randomly selected another. This experiment, this chance experiment can be represented in a diagram. First selection, what can we put there? "30 mangoes," here it is translated in symbolic form. 30 mangoes. Okay, you see that? So you see how words turn into symbols and then it looking algebraic. Okay, so you can actually read that. 30 mangoes. Okay, what else was in the basket? 25 apples, and that's how many fruits in all? 55 fruits in the first selection. So what must I type here? Okay, so let's just delete all of that. Go to insert, go to equations, put our capital P, capital P. What else? Open bracket, capital M, close bracket, what else? Equal. Okay, so the probability of selecting a mango in the first selection, as she's saying, is equal to 30 divided by the total amount of fruits, which is equal to 30 over 55. Okay, and she converted to a decimal. What did you get? 0.55. It's optional. You don't really have to convert it to decimal. You can leave it in fraction form. You don't even have to simplify the fraction. But for neatness, you can do it. But you'll not lose marks if you don't do it. Okay, so what next? What did you do after? So she go to the OR branch. That's another option. Okay. So in the first selection, a mango can be selected or what? Or an apple. Okay. A mango can be selected or an apple can be selected. Okay. And here she put the probability of an apple denoted as P of A is equal to what? (25 on 55), which is 0.45. Because in the first selection, okay, if you notice, in the first selection, there are 25 apples out of the total of 55 fruits. So the probability of an apple is actually 25 divided by 55, which is 0.45. And if you notice, for further proof, you can add 0.55 and 0.45 to get one example. What next? Second selection. So in the second selection, what can happen? The total frequency is equal to, you can either have, well, you must have 54 fruits, because the first fruit, whatever it is eaten. So there must be 54 fruits. But how 54 fruits can happen? You can have so mango after mango. So what numbers must I put there for mango here? 29 mangoes and how many apples? 25 apples. Okay, to give us the 54 fruits. Or what? So how many mangoes? So if an apple is chosen, how many mangoes? Here, we label in there. If it was an apple, how many mangoes? You will still have 30 mangoes, but you will have 24 apples. Okay, so that's the two ways that the 54 can happen. Okay, either you can have 29 mangoes with 25 apples, that's in the second selection we're talking about, or you can have 30 mangoes with 24 apples. You're realizing I'm not reasoning